click the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on our videos. Good day everyone, welcome back to another video on Smart Kite's tutorial video. Today I'm going to solve a question on electronics that says, for the circuit shown below, we can see a circuit shown below. Determine the T on, which is the time on, the T off, which is the time off, the duty cycle, and the frequency. Also, we are asked to describe how the circuit operates using its numerical timings and voltages. So, let's proceed. The circuit below is nothing but an unstable multivibrator that is implemented using 555 timer. Alright then, let's go ahead and bring out our data. So from the figure, we can see we're given 6 volts. This 6 volts is the VCC. So the VCC is given to be 6 volts. Next, we are given R1, which is our first resistance. This is our R1. So, R1 is equals to 2 kilo ohms. Then we are given R2, which is our next one. R2 is equals to 1 kilo ohms. Then next, we are given our capacitance. Okay, now here we would be thinking there are 2 capacitors attached to the unstable multivibrator. Well, you don't need to worry about this one because this capacitor is used for noise prevention. It is always connected to the control pin, which is called the pin 5, to the 555 timer. And this is not normally used in our calculation because it's just for noise prevention. To know more about 555 timer and how it operates, I would like you to share this video, subscribe, and comment if you want to know more. There will be a separate video on the operation of 555 timer and the use of each of the pin, their function, timing diagram, and everything will be provided in the video. So let's continue with this calculation. Now, as I said, we're not going to use this capacitor. We're going to make use of this other capacitor, which is C, given as 1 microfarad. Good. Now, these are the only things given. We can use this and continue our calculation. For an unstable multivibrator, the time on, which is the T on, is given as 0.693 into bracket the summation of the resistors, which is R1 plus R2, and C, which is the capacitor. This is also called the time constant. We know the time constant is given as RC, but here we are having R1 and R2. Well, for T off, the formula is 0.693 R2C. Now, let me explain this point. The T on is having R1 and R2 because as the voltage is being supplied, for T on, as long as the timer is on, it is going to charge through both the first resistor and also the second resistor. So that's why we're making use of R1 and R2. While when it is off, it discharges through the discharge pin by only R2 and R1 is not affected. Like I said, a detailed explanation on the operation will be given in the next video. Just share, subscribe, and don't forget to comment. I repeat again. Okay, now don't worry about this 0.693. It's just a constant. It's just a constant. Hold that 0.693. Okay, now let's go ahead and continue our calculation. Firstly, right, we are asked to find the T on. So T on is given as 0.693 into, what is our R1? 2 kilo ohms, right? Plus, what is our R2? 1 kilo ohms. And we have our capacitor, which is C. So times our capacitor is 1 micro. Yes, micro, so 10 raised to the power minus 6. Now, grab your calculators and calculate. What do you have as your result? Calculating this now, we have our answer to be 2.08 approximately millisecond. Milli because we got our answer in times of 10 times 10 raised to the power minus 3, right? So it's in milli. Now we have our time on. We can also go and calculate our time off. Our time off from the above formula is 0.693 into or multiply by R2 only. So we have 1 kilo multiply by our C, which is 1 micro, right? Good. Just 1 micro. So, again, grab your calculator and let's calculate. What are you having as your value? I'm sure it's something like 0.693 millisecond. Yes, you're right. That's the answer. Now, we have our T on, we have our T off. Now next, what are we asked to calculate? The duty cycle. Alright, now the formula for the duty cycle is given as duty cycle is given as T on over the summation of all the timings, which is T on plus T off. Now, what did we get as our T on? We had it to be 2.08 milli all over. Now, the summation of them, we have 2.08 milli plus, what is our T of? 0.693 milli. Now, what's our T of? 0.693 milli. Alright. Again, grab your calculators and let's calculate. 0.75. If you like, you can represent it in percentage, but I prefer representing it in percentage actually. It will look like more presentable. So this will be 75%. That's our duty cycle. Now, let's go next. What does the next one say? Frequency. The frequency. Can we all recall the formula for frequency? The formula in our physics that says frequency is 1 over period? Exactly. That is the formula we are going to use here to also get our frequency. Alright, now using that formula, our T. Now T is the total time. And total time, T, is given as T on plus T off. So we need to sum them. We have our T on to be 2.08 milli, right? Plus 0.693 milli. Alright, you can still grab your calculator and let's calculate the value of 2.773 millisecond. Alright, we can now go ahead and calculate our frequency from here. So frequency is given as 1 over 2.773 exponential minus 3 because of the milli. Now, let's get our answer. So, when you press it in your calculator, you're supposed to have a frequency of 360.62 Hertz. Alright, we have now gotten our frequency, we have gotten our duty cycle, time on and time off. Now, the next question says we should describe how the circuit operates using its numerical timings and voltages. We have all done the calculation. Now, in the next video, we are going to see how we're going to use all these timings that we got and all the voltages where we have our 6 volt VCC and all the timings we got, including T on, T off, total time, to get how this stable multivibrator operates. So please like, share and subscribe for the next video. So wait till then. There in details we are going to explain the operation of a 555 timer, that is the implementation of the stable multivibrator using 555 timer. Thank you everyone. Hope you liked the video.